Hello students, I Pooja Garg welcome you all in my YouTube classes for class 10th mathematics, and today we will do revision of chapter number 2 polynomials. And before going to start, like my videos, subscribe my YouTube channel Power of Mathematics, and don't forget to press bell icon so that you will get notification of all upcoming videos. So here in this we will do recapitulation of chapter number 2, and this is part 1. As you know, this chapter comprises of three topics, that is geometrical meaning of zeros of polynomial, zeros and coefficients of polynomial, and the division algorithm. In this lecture number 9, I am going to discuss only two topics, that is basic concepts and geometrical meaning of zeros of polynomials. And here let's see. So the here first is polynomial. A polynomial in one variable is an algebraic expression in the form of px, which is equals to an x raised to the power n plus an minus 1 into x raised to the power n minus 1 plus so on. Last term is a naught, where a naught, a1, a2, these are the constants or real numbers and the coefficients of the variable, and this n is a degree, should be a non-negative integer. And you know, if the term of a polynomial either arranged in ascending or descending powers of a variable, then it is said to be in its standard form. One more thing you have to note it down: an algebraic expression in which the variable occurs in the denominator or the exponent of a variable are not a whole number, then it is not a polynomials. So here you can see through some examples. Let's have a look. So here a polynomial cannot have division by a variable, negative exponent, decimal exponent, or an infinite number of terms. Here you can observe this radical symbol. Radical symbol, when we will remove, we will get power as half, which is in fraction. So it's not a polynomial. Now in this you have to identify which are the polynomials, which are not a polynomials. So yes, the very first and this third part is not a polynomials. Now the degree. Degree, as you know, the highest power of variable in a polynomial. So here you can observe, if the degree of a term in one variable is the exponent of the variable, if it has two or more than two variables, then we will take the sum of the exponents of the variable. Now under this we will do the classification of polynomials based on terms and based on degree. So based on terms you have already done in class 9, that is monomial, binomial, trinomial. If we have more terms, we simply call it as polynomial. But based on degree, we have constant polynomial, linear polynomial, quadratic, and a cubic polynomial. But in this chapter we will deal with the polynomials based on degree. So the very first one is linear polynomial, means a polynomial with degree 1, and its standard form is ax plus b, where a is not equals to 0. Second is quadratic polynomial, means degree 2, and its standard form is ax square plus bx plus c. Third is cubic polynomial, degree 3, and its standard form is ax cube plus bx square plus cx plus d, where a, b, c, d are the real numbers and a is not equals to 0. So students, you have to remember all these general form of these polynomials, that is linear, quadratic, and a cubic. It will help you a lot while doing questions. Next topic is zeros of polynomial. A real number k is said to be 0 of polynomial px if p at k is equals to 0. In other words, we can say 0 of a polynomial is that value of variable for which the value of polynomial is 0. It means for finding the 0 of polynomial, we need to equate that polynomial equals to 0. Now you can see few examples. The very first example is for linear. So here linear polynomial we can equate with 0. After solving, we will get x as minus 1 upon 2 is the 0 of polynomial. Second example is a cubic polynomial. After using three-step method, we will find the factors as x minus 2, x plus 3, 2x minus 1. For finding the zeros, we have to put px is equals to 0. We will get x as 2, minus 3 and half as the zeros of the polynomial. Now you can see in this example, here we have to equate this polynomial with 0. So we can conclude that if fx is a polynomial and y is any real number, then real number obtained by replacing x by y in fx is called the value of fx. But for the zeros of the polynomial, we have to equate the polynomial with 0. So students, as you know, number of zeros depends on the degree of the polynomial. Means if degree is 1, number of 0 1, degree 2, number of zeros 2, right? But number of zeros cannot exceed from its degree. Here you can remember these points. A linear polynomial has 1 0, quadratic polynomial has 2 zeros, cubic polynomial has 3 zeros, a polynomial of degree n has n number of zeros. But when we see it graphically, a polynomial with degree n has at most n number of zeros. Now we will see geometrical meaning of zeros of polynomial. Let px be any polynomial, then a point of intersection of graph y is equals to px with x-axis are the zeros of polynomial px. In this graph, you can see this graph intersect this x-axis at 3 points, means number of zeros is equals to 3. So following points you have to remember. The graph of polynomial px of a degree n can intersect or touches the graph at most at n points. A polynomial of degree n has at most n distinct real zeros. Now we will see general form of polynomial function. The very first one is linear, whose degree is 1, maximum number of zeros 1. You can observe the graph, it's a straight line. Second is a quadratic. Degree is 2, maximum zeros 2. Here you can observe this U-shaped graph. The shape of the graph is U. And this U-shaped graph we will call it as parabola. Means the graph of quadratic polynomial is known as parabola. Curve open upwards when a is greater than 0. Curve opens downward when a is less than 0. So here you can see these examples, these graphs. Now we will do for the cubic. Cubic means degree 3. Maximum number of zeros is 3. Now you can observe the graph of the cubic polynomial. After this, I am going to give you some assignment questions. So you can pause the video and write down the questions. These are very basic questions based on the video. And students, in next video, I am going to continue with the remaining 2 topics. Thank you for watching my video. Keep on watching, keep on practicing. And don't forget to write your class name, roll number in the comment box.